The main actor in the invention of the wireless telegraph was the idea of the aura, without which today's digital world would never exist. James Clerk Maxwell in the 1850s. He was the very mysterious human genius who discovered the idea of aura generated from a combination of electricity and magnetism. Why do we say Maxwell is a mysterious genius? Because he has a different background for an inventor. Maxwell was born into a Scottish clerk family. Clans who often do strange research, according to Ron Halliday in his book, Famous Scots and the Supernatural. Here Ron also writes that this family is affiliated with Charles Piazzi Smith, an astronomer who is actively studying the pyramids of ancient Egypt. His writings on the pyramids inspired Charles Taze Russell to form a group of Jehovah's Witnesses. Uniquely, his sister, Henrietta Grace Smith, is the biological mother of Robert Baden-Powell. The most important value of Maxwell's opinion is, many general equations can occur in all circumstances. This means that between all the differences there must be similarities. Departing from his heart, then Maxwell found the idea of aura and called the aura earlier with the term wave. These waves move very fast at a speed of 300,000 kilometers per second. Incredible speed, putting yourself at the speed of light. This is what Maxwell called the equation earlier. He rightly concluded that light consists of electromagnetic waves. Yes, electromagnetic wave. That's the name of the aura we described earlier. This led to his ideas, not only discoveries in the field of electricity and magnetism, but also discoveries in the field of optics. Light that is visible to the eye is not only the type that contains electromagnetic waves, invisible light can also. This theory was amazingly realized by Rudolf Heinrich Hertz and met both waves that were visible to Maxwell's eyes of prophecy. Why is there a role for Rudolf Heinrich Hertz in the case of electromagnetic waves? Wasn't in the previous session he played a role in the case of sound waves? This is the time to prove that our material does not completely deviate from the main topic. Okay, we will answer interesting questions with interesting too. In physics, there are various waves. We will discuss enough based on three categories, namely waves based on the medium of propagation, waves based on the direction of vibration and propagation, waves based on the direction of vibration and propagation, and waves based on their range. This category is filled with mechanical waves and electromagnetic waves. Waves that require propagation media ranging from solids, liquids, and gases. Examples include sound waves. Sound here is any sound, audible to the ear or not. The waves are clear because they include liquids. Likewise, earthquake waves propagate through solid objects such as soil, rocks, and trees. In contrast to electromagnetic waves that do not need anything to propagate, this wave of ideas from Maxwell is indeed strange. For example, the antenna waves in wireless telegraphs, such as Maxwell's study of light, also include lamps and other objects that emit light.
What?
Is the light of the sun, stars, moon including electromagnetic waves? Yup. Electromagnetic waves can occur because of humans, but they can also occur naturally by God's work such as the moon, sun and stars. They revolve around the earth by electromagnetic force. Of course, without electromagnetism, they do not move and glow.
Oh, gitu.
So is all natural light due to electromagnetic forces? No. In this incident, yes. But not for the rainbow phenomenon. The second category of waves are longitudinal waves and transverse waves. We can see in this spring, the direction of vibration and their propagation is different. For example, all sounds produced and heard by the human ear are called autosonic waves, and those that are not audible to humans such as ultrasonic waves and infrasound waves. While the transverse examples of light waves, springs and ropes. The last wave is based on the distance traveled or the amplitude. There is a traveling wave with a fixed amplitude, for example a water wave. Water is a special liquid, that's why this phenomenon occurs. The opposite is a stationary wave or a standing wave or a stationary wave. It has the same amplitude and moves, for example the strings on a string instrument.